Greetings, everybody. I wanted to talk briefly about single replacement reactions. These are very, very simple reactions. So in a single replacement reaction, all of them, they're going to look something like this, okay? I'm going to use some different colors here. Hopefully this will help you to process what we're talking about. So they all have it where they go A, that it's going to be a lone element, B plus, B, C. And so what's going to end up happening is the person that gets replaced is this cation that is on the front of the compound. In all single replacement reactions, you have some lone element here, usually a metal, but some lone element. This is some aqueous solution where B is your cation. So students, what's going to happen is A will replace B. And so it looks something like this, where now we have A, C plus B. And so this is sort of the 30,000 foot view of what single replacement reactions look like. So let's take, let's say that we are actually to take a piece of solid aluminum, and we were to take that piece of aluminum and put it or immerse it in a copper 2 chloride bath. What's going to happen is that the aluminum, notice that the aluminum is an element, okay? Copper is in solution, is a cation, it's charged. What's going to end up happening is they're going to flip-flop. So another way stated, the aluminum now is going to be in solution with the chloride, and rather remarkably, copper comes up out of solution. Another way stated, it comes out as pure copper. So that's one of the neat effects of these reactions, okay? In that here we have an element, okay? And when they do this whole flip-flop, an element comes out, okay? So an element should always be a product of these single replacement reactions. Again, you can see that only one thing is being replaced, which is why they call it a single replacement reaction. You may have noticed that I had to place 3 chlorines there. That's not a mistake. Remember that aluminum has a common charge of +3. Each chloride has a charge of -1, which means if you do your crisscross, we need the 3 chlorides to balance the charge on the aluminum. Obviously, this is an unbalanced reaction, but I don't want to get lost in that. I just want you to see the 2 major components here, in that this copper here is replaced by this aluminum. And so this is a single replacement reaction. Pretty easy to write. Again, one major takeaway for everybody. It is the cation of the compound in aqueous phase that gets replaced. Just remember that, okay? Last but certainly not the least, I want to show you how we are normally going to write these reactions. Clearly this is not balanced. Let's go and balance this reaction real quick. Now that should be a balanced chemical reaction. Let's identify those spectators real quick. So hopefully you can see that the only spectators that we have are actually just the chlorides. Just the chlorides. So hopefully at this point you can kind of jump right to the net ionic, okay, without having to go through the ionic equation. So we know that the aluminum, is going to be a part, and there's 2 of them, so aluminum. The coppers will be, so that'd be 3 Cu. We can tell it's got a 2+ charge because there are, of course, 2 chlorides with a -1 charge, which tells us there has to be a copper with a +2 charge. Moving on. We have 2 aluminums with a 3+ charge. Again, your chlorides are spectators, so they canceled out, +3 copper in solid. And so this would be your net ionic, and this is the way that we're going to see a lot of these reactions written in this unit.